Hello everyone, welcome to this another exciting discussion on machine learning. On this video, I am going to discuss in full how are we learning as a human and how machine learning. Before we proceed, these are the topics that we are going to cover. What is machine learning, the classification of machine learning, the sourcing of data, the life cycle of data, training of data set, and of course, some of the use cases. Basically, humans are learning based on personal experiences, which starts from the time of our curiosity. From the start, we see things. From the start, we heard voices of people around us. It is a natural process of learning. On the other hand, machines are learning based on the historical data and records. The influx of big data makes machines more and more intelligent. Everything that we do online, everything that we post online, contributes to the machine intelligence. Data can be sourced from available data sources. There are many publicly available datasets that can be used for machine learning projects. A public data source is a repository of data that is freely available to the public and can be used for various purposes, such as research, analysis, and machine learning. Public data sources can come from a variety of organizations, including government agencies, nonprofit organizations, and research institutions. Here are some of the examples of popular public data sources. The United States government agencies. The United States government provides access to a wide range of data through websites like data.gov, the Bureau of Labor Statistics, and the U.S. Census Bureau. Second is nonprofit organizations. Nonprofit organizations like the World Bank and the World Health Organization provide access to data related to global development and health. Research institutions. Research institutions such as universities and think tanks also provide access to data related to various fields of study, such as economics, psychology, and environmental science. Social media platforms. Social media platforms like Twitter, Facebook, Instagram, YouTube, and many others provide access to data through APIs, allowing developers to build applications that can extract data from these platforms. And of course, from different data repositories. Online data repositories like Kaggle, UCI Machine Learning Repository, and OpenAI provide access to a large collection of datasets for various purposes. Some organizations have their own proprietary datasets that they can use for machine learning projects. These datasets may not be publicly available but can still be used for research and development purposes. Private data sources are data repositories that are not freely available to the public and are usually restricted to specific organizations or individuals. These sources are usually maintained by private companies, research institutions, or government agencies for their internal use. Some of the examples of private data sources includes the enterprise data warehouses. Large corporations often store vast amounts of data in data warehouses for internal use and analysis. This data may include information about customers, sales, marketing, and operations. Clinical trials data. Data generated from clinical trials is usually confidential and not accessible to the public. It is typically maintained by pharmaceutical companies, research institutions, and government agencies. Consumer data. Companies that collect data on consumer behavior and preferences, such as search engines and e-commerce websites, often maintain large databases of this information for internal use. Government agencies. Some government agencies may maintain confidential data such as the national security or law enforcement data, which is not also available publicly. Financial data. Financial institutions such as banks and investment firms also maintain large amount of confidential data and information, such as the transaction records and the customer's information. Private data sources are valuable for organizations that need to maintain the confidentiality of their data. They can be used to support decision-making, improve operational efficiency, and gain a competitive advantage. However, accessing private data to sources often requires special permissions and may be subject to strict regulations and laws, such as the data privacy laws. Data can be scraped from the internet using web scraping tools. This can be useful for collecting data from websites, social media, and other online sources. There are website aggregators. Travel agencies, for instance, are connected and integrated with different airlines. Scraping tools are software applications that automate the process of extracting data from the websites or other sources on the internet. These tools, used by businesses, researchers, data scientists, and other individuals who need to gather large amounts of data in efficient and automated manner. Some of the popular scraping tools include Beautiful Soup. This is an open source Python library that is used for web scraping purposes to pull the data out of HTML and XML files. Scrappy. This is also an open source and collaborative web crawling framework for Python. Octoparse is a visual scraping tool that requires no coding and can be used to scrape data from websites, social media, platforms, and other sources. ParseHub is a cloud-based web scraping tool that allows you to scrape data from websites and APIs without writing any code. WebHarvey is a point-and-click web scraping tool that is easy to use and allows you to extract data from websites and save it in various formats. There are other companies that uses a commercial web scraping tool such as the Embarcadero. You can also collect data by conducting surveys, interviews, or experiments. This can be useful for collecting data that is not available in public or private dataset. This is what we call the first-hand information or the first-hand data. Data augmentation, on the other hand, is a technique used to increase the size of a dataset by generating a new data from the existing data in the context of a dataset. Data augmentation can be performed by applying various transformations to the data, such as rotations, scaling, translations, and flipping. The goal of data augmentation is to increase the diversity of the data and reduce overfitting, which occurs when a machine learning model becomes too closely fit to the training data. Data augmentation is often used in computer vision and image processing tasks, where the size of the dataset may be limited. By applying various transformations to the existing images, a much larger dataset can be generated, which can then be used to train more robust models. For example, if a dataset contains images of faces, data augmentation can be performed by rotating the images, scaling them, flipping them horizontally or vertically, or adding noise to them. These transformations can produce a much larger dataset that is more diverse and better represents the underlying distribution of the data. In general, data augmentation can be a powerful technique for improving the performance of machine learning models, especially when the size of the dataset is limited. By generating new data from the existing data, data augmentation can help needs to generalize better and avoid overfitting, which can lead to improved accuracy and robustness of the model. A synthetic data is a generated dataset that mimics the characteristics and patterns of real-world data. Synthetic data is typically used as a substitute for real data when the latter is not available or cannot be used for privacy, security, or ethical reasons. Synthetic data can be generated using various techniques such as simulation, sampling, and random generation. The goal of synthetic data generation is to produce a dataset that closely resembles the underlying distribution of real-world data, while preserving the important characteristics such as the relationships between variables and the distribution of values and the patterns in the data. Some of the examples of synthetic data sources includes the financial data. Synthetic financial data can be generated to mimic the real-world financial transactions and prices, and can be used to test financial models and algorithms. Healthcare data. Synthetic healthcare data can be generated to represent patient information, medical records, and test results, and can be used to train machine learning models and test algorithms. Customer data. Synthetic customer data can be generated to represent demographic information, purchasing habits, and other characteristics, and can be used to train machine learning models and test algorithms. Synthetic data sources are useful in a variety of applications, including machine learning data, data privacy, and software testing. By generating synthetic data, organizations can obtain a large, diverse dataset that closely represents the real-world data, while avoiding the challenges and the risk associated with using real data. Additionally, synthetic data can help organizations to comply with regulations such as data privacy laws that may restrict the use of the real-world data. Thus, human is the source of machine intelligence. Everything that we do, everything that we publish, and everything that we store in different data repositories will become the source of machine intelligence. So be careful with what we post, be careful with what we store online. Because technically, at the end of the day, machine may able to see this online. Alright, so technically, machine learning is defined as a type of artificial intelligence that allows software applications to predict outcomes without being explicitly programmed. Machine learning algorithms are using historical data as an input to predict new values and or to predict unknown values. Based on its scientific definition, there are algorithms that doesn't require programming skills. For data for the machine to learn things, to predict things, or unknown things. It requires human intervention to teach. It requires human intervention to help machine understand what we want to achieve. In other words, machine learning is a subfield of artificial intelligence that focuses on the development of algorithms and statistical models that enable computers to learn from data without being explicitly programmed. The learning process involves training a machine learning model on a dataset, which allows the model to make predictions or decisions about new data. There are three main types of machine learning: the supervised learning, unsupervised learning, and the reinforcement learning. In supervised learning, the machine learning algorithm is trained on labeled data, meaning that the output or target variable is known. The goal is to learn a mapping between the input features and the target variables, so that the model can make accurate predictions on new unseen data. Examples of supervised learning include linear regression, logistic regression, and decision trees. Unsupervised learning. In unsupervised learning, the machine learning algorithm is trained on unlabeled data, mapping that the target variable is not known. The goal is to uncover hidden patterns or structures in the data, such as clusters or associations. Examples of unsupervised learning include the k-means clustering and dimensionality reduction. And the third is the reinforcement learning. This is the machine learning algorithm that interacts with an environment, learning from the experiences to maximize a reward signal. The goal is to learn a policy which maps states of the environment to actions, so that the algorithm can make decisions that lead to the highest reward. Examples of reinforcement learning includes game playing AI and robotics. The process of training a machine learning model involves the following steps. Data preparation. The first step is to gather and pre-process the data that will be used to train the model. This includes cleaning the data, handling missing values, and transforming the data into a suitable format for the algorithm. Next is model selection. The next step is to select a machine learning algorithm that is appropriate for the task at hand and the data. This may involve comparing different algorithms and selecting the one with the best performance on a validation dataset. Model training. The selected algorithm is trained on the prepared data. The training process involves updating the model's parameters so that the predictions made by the model are as close as possible to the true and real values. Next is the model evaluation. This is the final step, and the goal is to evaluate the performance of the trained model on a data set. This allows the algorithm's performance to be measured and compared to other algorithms. Once a machine learning model has been trained and evaluated, it can be deployed in a real-world setting to make predictions or decisions about new data. The model may also be retrained on the new data as it becomes available, allowing it to continuously improve and adapt over time. Training and testing data sets are essential components of machine learning process. They are used to train and evaluate the performance of machine learning models, respectively. A training data set is a subset of the data that is used to train a machine learning model. The model is trained on the training data set by adjusting its parameters so that it can make predictions that are as close as possible to the actual or the real values. The goal of the training process is to find the model parameters that give the best performance on the training data. A testing data set, on the other hand, also known as the validation or the holdout data set, is a separate and distinct subset of the data that is used to evaluate the performance of the trained model. The testing data set is not used in the training process and provides an independent evaluation of the model's performance. The model's predictions on the testing data are compared to the actual values to assess the accuracy, generalization ability, and the robustness of the model. It is important to use separate training and testing data sets because the goal of machine learning is to make predictions on new, unseen data. By evaluating the model on a separate testing data set, you can assess its performance on the data that it has not seen before, or ensure that it is not overfitting to the training data. Overfitting occurs when a model is too complex and performs well on the training data but poorly on the new data. Typically, the data is split into a training and testing data set, with most of the data being used for training and a smaller portion being used for testing. The exact split between training and testing data depends on the size of the data and the specific requirements of the task. But a common split is 80 to 20%. 80% was used for the training and 20% was used for the testing of the dataset. Or some other analysts are using 70-30 cuts or split. In some cases, additional validation datasets may be used, such as a cross-validation or the bootstrapping, to further assess the performance of the model and reduce the risk of overfitting. These techniques involve dividing the data into multiple subsets and using the different combinations of data as the training and testing datasets. Now that we are already aware of how machine learning and we are already aware of the processes involved that is common to the different classifications of machine learning, let us now explore and discuss the supervised machine learning. By definition, supervised machine learning is a type of machine learning where the algorithms are trained on labeled data to make predictions. The labeled data consists of input features. This is also known as the independent variables, and the output labels, also known as the dependent variables. This is one of the common practice in supervised machine learning. This is what we always do. The goal of supervised learning is to learn a mapping between the inputs and outputs, and use this mapping to make predictions on new or the unseen data. There are two main types of supervised machine learning: the regression and the classification. In regression, the goal is to predict a continuous value, such as the price of a house, whereas in classification, the goal is to predict a categorical value, whether a customer will buy a product or not. Another example of classification is whether an employee will attrite or will stay in the company. Supervised learning is called supervised because the learning process is guided by labeled data, and the model is trained to predict the correct output based on the input features. The quality of the predictions made by the model is determined by how well it has learned the relationship between the inputs and the outputs. And this is evaluated by comparing the predicted outputs with the actual outputs on a separate evaluation dataset. Attrition refers to the gradual loss of employees from an organization over time. It can occur due to a variety of reasons, such as retirement, resignations, or death. In a business context, attrition is often used to describe the loss of employees because of resignation or retirement. High attrition rates can indicate issues within the company, such as poor management, low morale, or inadequate compensation and benefits. Attrition can have a significant impact on a company's operations, as the loss of experienced and skilled employees can lead to a decrease in productivity and, of course, an increase in training and recruitment cost. To mitigate the effect of attrition, companies may implement retention strategies such as offering better benefits, improving the work environment, or providing opportunities for career growth and development. In addition to its effects on the workforce, attrition can also have financial implications for a company. For example, high attrition rates can result in the loss of valuable knowledge and expertise, as well as the increase in the cost of recruiting and training new employees. To maximize this cost, companies may implement retention programs aimed at keeping employees engaged and become more motivated. To illustrate regression supervised machine learning, over the past few years, company XYZ notice that they have increasing number of resignations. Based from the results of the exit interviews, most reasons was that employees have found higher salary offers. The reason was about salaries and compensation. And to prevent this situation, companies may implement retention strategies such as offering a better salary rates. Thus, they spearheaded a study to standardize their salary offer for new hires to make sure that they can provide a better and a competitive salary offers. To illustrate regression from classification, here is the data from Kaggle. To prevent attrition, companies have conducted a study to standardize their salary offers. Thus, the dependent variable used in the study is the monthly income, and the independent variables used includes business travel, departments, and so on and so forth. To do this, they will have to perform multiple linear regression to predict the standard salary rate that they can offer to the new hire. And of course, on the basis of the independent variables. To illustrate the classification supervised machine learning, they have conducted an additional study related to attrition. In this case, they have used the attrition status as the dependent variable. The goal is to predict the probability that a certain employee will attrite at a certain level. To do this, they will have to perform logistic regression. Of course, on the basis of the independent variables. Alright, so this is how a supervised machine learning model works. Okay, so the next video will discuss how unsupervised machine learning model works. What is the process? What are the things that we need to look into when we perform a supervised machine learning model? Alright? There you go.